Okay, Matrix, let's just quickly recap on our definition of logs. If you have y, have a look at y equals a to the x, that's an exponential graph. Remember, the most important thing is that your base can be between 0 and 1 or bigger than 1, but a can never equal 0, a can never equal 1, and a cannot be a negative number. When we invert this, we get the inverse of the exponential, its log. And remember, that's a base there. We introduce this by going log x to base a is equal to y. Okay, that's the inverse. So if that is f, that is the inverse. Now, the theory of logs is important. You also have an added condition here, is x is positive. So that's quite important, just to recap from last time. And remember that the exponential graphs are quite easy. The one looks like this. That would be increasing exponential. The log graph does that. And for the decreasing graphs, it goes down like that and like that. Okay, that's the log graph. So that's pretty much what we did last time. But there's some wonderful laws. Now, you don't have to worry about them too much, but if we just recap a little bit on the laws of logs, or not recap, you don't know this at all, but there's some wonderful rules of logs that they've actually developed you can prove, but we're not going to really get into this. If you've got the log to base a and you're multiplying, okay, you're multiplying, there's a law that actually says you can go log x to base a plus log 1. Now, I'm not going to prove this. I just want you to accept this. Log x times y to base a is log x plus log y. Okay. The second law of logs that is quite useful. If you got log to base a and you divide the x by the y, you can then subtract. You say log x to base a minus log of y to base a. In other words, division goes with minus and multiplication goes with plus. Okay, these can be proved. They're very interesting, but we're not going to get too much into that. The third law of log says, this is a wonderful one, if you say log x to base a and there's an exponent up here, you can bring it down next to the log, and there we go. Okay, that's the third law. There is a fourth law which sometimes comes up, and we'll explore that as well a little bit. I just want to comment on that. It's called the change of base law, but it says if you've got log x to base a, you can actually write log x divided by log a like that and change to any other base that you want. Again, a lot of proof is needed for that. Okay, just to look at the examples quickly, we're using these laws. If we look at the first law of logs, if you had, for example, if you had log 4 multiplied by 3 to base 2, that could actually be log of 4 to base 2 plus log of 3 to base 2. And it would apply if it's divides. You actually do the same there. And we're going to explore examples involving this. Watch out for this law as well. Don't worry too much about the change of base at this stage. But let's look at some examples involving the first law of logs, where you add and multiply, subtract and divide here. And this is the little one with an exponent there. You bring it down, and law 4 is the change of base, which we'll look at as well. Now have a look at this. What's quite nice, there's another thing as well that you can, which we call deductions as well. The deduction 1 would be if you've got log a to base a, that is 1. The reason why this works is you'd probably agree as a is the same as a to the 1. Now if that goes underneath there and becomes a base, you've got log a, and then this here goes to this point there, and you get 1. The other important, so for example, if you had log 4 to base 4, that would be 1. Okay, the other deduction, which is quite fun as well, deduction 2. What deduction 2 says, if you've got log of 1 to any base that's meaningful, is 0. Now, for example, you'd agree that 1 is equal to a to the 0. So if you then apply log laws, that a goes underneath, that becomes log of 1 to base a is 0. So the log of 1 to any base that you like is 0. By the way, another thing that's quite useful, whenever you talk of log x to base 10, we normally just write it as log x. We don't write that 10 there. It's called the common logarithm. So be careful of that. Now let's put this all together. Remember, they're not going to test you too in too much detail, but it might be worthwhile just to look at the little logs, and then we'll get into the really where it's important. If they asked you to simplify this without using a calculator, if we just take this quickly, well, what do you notice? Okay, the bases are the same, alright, and what can we do? Okay, so if you look at the first law of logs, what is the first law saying? It says, well, you can reverse this as well. You can add, if you've got these two added, you can multiply. So what we're doing is we can do with this, we can say, well, the thing that the base is the same, we can say log, write it as 1 log to base 9, and we say 27 multiplied by 3. That's the first law. In other words, if the base is the same and you're adding the logs, you can write 1 log and multiply. So what happens now, this is quite fun, because this equals the log to base 9 of 81. Now, watch this. The log to base 9, 81 is 9 squared. Okay. If I look at the third law of logs, if you look at the third law there, it says you can bring that exponent down. Okay, so if we apply that, now watch this. If we apply that, we can bring the 2 down, and it gives us log 9 to base 9. Now come on, what is log 9 to base 9? Is 1. That's one of our deductions. Look at that, log 9 to base 9. Exactly the same. Log A to base A is 1. And there we go. So if you look at this, it comes to an answer of 2. Okay, so this is just some basic laws of logs. I wouldn't get too stressed with them, but they might be worthwhile knowing at times. Have a look at another one quickly. If we apply another one, example B here, if I said to you the log of 27 to base 3 subtract the log of 3 to base 3, well, because the base is the same and we're subtracting, we can write log base 3 and actually divide the 27 and the 3, which of course gives me log to base 3 of 9. 27 over 3 is 9. And then look at this. This gives you log 9 is 3 squared. Okay, bring the 2 down. Log 3 to base 3. And what is log 3 to base 3? Is equal to 1, and once again our answer comes out at 2. What a pleasure. Okay, let's look at a few more other types quickly, and then we'll get into the change of base rule as well. Okay, another one, number C. What if you had something like this? Log of 16 divided by log of 4. Well, what we need to really do, if you think about this, is probably the best way is to think about, I mean, if you take 16, it could be 2 to the exponent 4. 2 to the 4 is 16. The log of 4 is log 2 squared. Okay, and then all we need to do is bring down the 4, use the third law, 4 log 2. Remember the base here is 10. It's the common logarithm divided by 2 log 2. And of course, what's nice is those cancel, and 4 over 2 is 2. Okay, so that's quite a nice little one there. In the notes, you'll see there's another one you can look at as if you want to. As I say, I'm not getting too technical with all of these things. They're not really that necessary. The only thing that I could say is, in terms of that specific example, if you had log 100, that is the same as log 10 squared, but the base, imaginary base, is 10. Then we bring the 2 down, log 10 to base 10, and log 10 to base 10 is of course 1. Now you can of course do that, which is totally acceptable there. You can do that as well, but there are other examples in the notes that you can look at, but I'm not going to get too much into this. The other one is a change of base rule. If you have a look at this one, again, they're not going to really test you on this, but I just thought I'd just expose you a little bit to these rules. Okay, log 27 to base 9. Well, you can't do much with the 27. 9 to the what is 27? But what we could do is we can change base. Now, you can actually do this. You can change to any base you want, and if we could, we would change to base 10. That's always your easiest bet. Then look at this. This is log 27 is 3 cubed, and 9 of course is 3 squared. So if you bring the 3 down, 3 log 3 divided by 2 log 3, and what would that give us there? That would then cancel, and the log 3's would cancel, and you're left with 3 over 2. There are other ways. You can change to any different base that you want. You can see in the notes that's exactly what I've done. Now I'd like you to try a practice example, but people, I don't want you to get too involved with these laws. Okay, if you look at all these laws of logs and it's great, but it's not really what it's about. Okay, we just do it a little bit to show you what the log law is about.